Hello, in this video I'm going to talk about two operators that Lantern's language supports that are not going to be found in any other language because they're simply for doing adventure game things. That is has and sees. These are mathematical operators because they return either a 1 or a 0, true or false. And what has does, it tests is the thing on the right anywhere in the thing on the left's inventory, either at the top level or anywhere else. So when you check something's holder, if you say, is the flashlight's holder the player, what you're saying is the player the immediate parent of the flashlight in the object tree that represents the game. However, maybe you don't care whether it's in the player's top level inventory. Maybe you just care whether it's anywhere in the player's inventory. That it's in a box, in a bag, in a sack that the player's carrying. The player still has it. It's just not that, but that object's holder isn't the player. It's the container it's in. This stuff only really pops up if the player if there's portable containers in the game. Otherwise, you can just get away with checking if the object holder the player. However, if you've got scenarios where you're checking to see if the player has something, but it's in a container that the player is carrying around, then you can't check the holder. Then you have to use has, and has just bubbles up the object tree, trying to see if I start at this object and I bubble up the object tree, do I eventually hit this object? It's checking for ancestry. Is this thing on the left an ancestor of the thing on the right? And then the other operator is very straightforward. It's just, does the thing on the left see the thing on the right? And that takes into account nested containership and whether the containers are opened or closed. So if I put something in a bag or a box and the box is open, then I can see it, or so can anyone else in the room. And if I close the box, then I can't see it. So let's take an example of how this works. And I apologize if you're a cat lover. I think I had just saw some cartoon about Schrodinger's cat when I was crawling, looking through Facebook, and I don't know, this is a bad example, but let's just take a look. I apologize if you like cats and you don't like the example. I totally get it. So what I've done here is I've created an event, and events run every turn, and it says, hey, if the player has the cat either in his top level inventory or not, if the cat is a descendant down the tree of the player, or the player is an ancestor up the tree of the cat, then print the player has the cat, otherwise the player does not have the cat. And I've got another test here that says, does the player see the cat, right? So if the player's in an open container in the room, then the player would see it. If the container is closed, then the player wouldn't see it. So let's just test it and see if it works. Well, it'll actually work. Let's just see what happens here. Let's just demonstrate it working. So let's look here. So I'm in a room, just a little test room, and if I type, you can see it says the player has the cat, the player sees the cat. And if I type I, it says I'm carrying a bag, the bag contains a cat, right? So I'm carrying an open bag. Now if I close the bag, you'll say, it says the player has the cat, but the player doesn't see the cat, right? And if I try to drop the cat, it should say you don't have that. Actually, it really should say you don't see that. But maybe you're carrying around a locked box and you don't know what's inside it. So you shouldn't be able to access it somehow. So there it is. It's doing a visibility check. The cat is in a container, and the container can be open or closed. And whether the container is open or closed determines whether I can see it. Now I have it either way, but because I'm carrying the bag. And then let's drop the bag. So it says that the player does not have the cat, right? Because the bag's holder is no longer the player; it's the room the player's in, and the player does not see the cat because the bag is closed. And now I can open the bag. It says the player does not have the cat, but the player sees the cat, right? So this can be used for puzzles again, like I can't remember if I mentioned it, or stream of consciousness, but imagine you've got a cave full of gold coins. There's a pile of gold coins. You have to get them past the dragon, and you have a canvas bag, right? You put the coins in the bag, and then you have to walk through the room with the dragon. You could test does the dragon see the coins? And if the dragon sees the coins, then he breathes fire and kills the player. And the player's got to figure out, okay, hang on, that canvas bag. Oh right, if I put the coins in the canvas bag and then I close the bag, then, or I put them in a box and I close the box and I can walk out. Maybe there's a box in the game that says definitely not coins, right? That would be funny. All right, I'm going to put that in a game, and that way you can. It just gives you a little more richness in terms of how you can manipulate objects or test things, conditions that may exist in your game. So there you go. There's two mathematical operators that exist in Lantern that don't exist anywhere else. Has and sees, and they are used for testing containership and visibility.